Hello, my name is Anagha Bhuvanagiri. I'm a rising junior in Maryland, and my mentor is Sarah Hussein. Our research project is in the field of bioinformatics, and we used elastic net regression to analyze the highest indicators of survival in lung cancer patients after receiving immunotherapy. So first I'll be going over the data set, and then next I'll go over the key terms, and then methodology, results, and next steps. So for the data set, we used two data sets. First, the training data set, and then the testing data set. The training data set is the data set we used to train our model. It contains the gene expressions that we evaluated for this project. And then the testing data set is the data set we used to test validate our model. This is important because we need to make sure that our model works with other data, not just our own data. Both data sets contain 249 genes and 72 patients' gene expressions, and then each patient has two possible responses, 0 and 1. 0 meaning that the patient did not survive after receiving immunotherapy, and 1 meaning that the patient did survive after receiving immunotherapy. So some key terms for this project. ElasticNet is basically a subset of binomial regression that helps us combine different penalties. Basically, this penalizes our data set until only the significant genes remain. This symbol here is alpha. Basically, alpha is a decimal value that ranges from 0 to 1, and it penalizes our data set to only include the most significant genes. An alpha value of 0 means that there's no penalty added, and an alpha value of 1 means that the most possible penalty is added. And then this second symbol here is called lambda. Lambda is a shrinkage parameter that further penalizes our data set, and it's determined through cross-validation. Cross-validation basically determines the best lambda and also outputs an AUC, which we'll talk about later. Test validation is another form of validation where we use a different data set and apply it to the model to see our ElasticNet model's performance against another data set. Like I discussed in the previous slide, it's pretty important because we need to make sure that our model works with many different data sets, not just our own. The AUC is the area under the curve. Basically, it's just an accuracy and performance measure that shows us how accurate our model is in predicting patient survival. The ROC curve, or the receiver operating characteristic curve, is a graph that helps us visualize the accuracy of our model using the TPR and the FPR. The TPR is the true positive rate, which basically tells us how accurately our model can determine patient survival, and FPR is the false positive rate, which tells us how inaccurately our model determines patient survival. And then finally, feature importance is how predictive the genes are in indicating patient survival. In the end, we will show you graphs and results to help visualize all these definitions. So onto the methodology. First, we installed libraries. We used the R programming language, and the R programming language contains many different libraries that have built-in functions that we heavily utilized throughout our project. Second, we utilized all of our genes and trained our model using the training data set. Third, we used the setSeed function, which basically allows us to save our results and access our results from an online browser instead of having to save our data to a device. And then fourth, we created a for loop to reproduce our data for different alpha values. So for this project, we used two different alpha values, 0.5 and 1. The reason why we use these two alpha values is to see the progression of the AUC, or like the accuracy measure, as the alpha value increased. Fifth, we cross-validated our model using the GLMNet library and obtained our lambda values. Sixth, we developed the ElasticNet model using the lambda values and the alpha values. Seventh, we plotted the significant genes with BIP. And then eighth, we created our prediction model. And this is basically the test validation, where we input our testing data set into the ElasticNet model to see how well our model performs with the second data set. And then ninth, we determined the AUC of the testing data set and the cross-validation. And then last, we created our ROC plots. So on to the results. So for alpha value 0.5, this is the cross-validation model. We obtained a lambda value of 0.015 and an AUC of 0.796. This red line here basically is the real actual AUC value. And then this gray area is the confidence interval. So this upper bound is the highest AUC value we could have gotten with this lambda value, and then this lower bound is the lowest possible AUC value we could have gotten. So this is the VIP chart for alpha value 0.5. These are the most significant 20 genes in our ElasticNet model. So as you can see here, gene 136 is the highest predictor with an importance of about 0.0275. And although this number may seem small, it's actually pretty big, especially if you compare it with the other genes in the model. And then finally, here's our rock plot for alpha value 0.5. We got an AUC of 0.913, which is very high. So as you can see on this x-axis is the false positive rate, and then the y-axis contains the true positive rate. We want the false positive rate to be as low as possible and the true positive rate to be as high as possible. So as you can see, this line goes pretty close to the top left corner, which is really good. So on to alpha value 1. This is the cross-validation model we got for alpha value 1. The best lambda value we got is 0.002, and the AUC is 0.827. This is the VIP chart for alpha value 1. These are the most significant 20 genes in the ElasticNet model, and then as you can see here again, gene 136 is the highest predictor with an importance of about 0.065. The importance here is bigger because with alpha value 1, there are less genes left in the dataset to be compared, so that the most significant genes have a higher importance. And then finally, here's the rock plot for alpha value 1. Here we got an AUC of 0.898, which is still very high, and there's a low false positive rate and a high true positive rate. So finally, for next steps, these studies can increase our confidence in predicting patient survival. Immunotherapy treatments can target significant genes and increase patient survival. Just last year, atezolizumab was approved to treat some patients with non-small cell lung cancer. Here, we can use a real-life application of our studies to determine which patients are most likely to survive with this medication. All in all, curating therapies and treatments for cancer can help guarantee that survivors enjoy longer and higher quality lives. Thank you guys so much. Special thank you to Sarah Hussein for being such an incredible mentor throughout the past 2 months. And thank you to the Talaria community for giving me such a great opportunity to conduct research.